Okay, so we covered multiplication, we covered addition and subtraction, but we were yet to touch division. There's a particular reason why, and it's because division's a slightly more complicated process, both intuitively and computationally. So that's why I've devoted separate videos to algebraic division. Now, the main method that people are taught is the bus stop method, where you have one polynomial, bus stop, and another polynomial. I absolutely hate teaching that method. The reason I say that is because I find the students get lost on it like way too much. There's a lot of parts of the process, and it doesn't really work as efficiently for higher order polynomials. It often requires a lot more steps. So how I teach it is by doing a thing known as the degree method, and we're actually going to exploit this. So how I go about this is kind of rearranging this a little bit. So what we can note is if we were to solve this, x squared plus 3x plus 2 all over x plus 1, because we're dividing, we'd actually subtract the degrees. So when we're multiplying, we add, so it kind of steps down a level, and we can note that when we divide two polynomials, the degree of the division is simply the difference of the degrees. Now note that this doesn't really work if the degree of P2 is much larger than the degree of P1, because at that point we wouldn't actually end up with a polynomial. So this is only provided that the degree of P1 is greater than the degree of P2. So in how we do this, we have a degree 2 on the top and a degree 1 on the bottom. So we're going to get some generic degree 1 polynomial occurring on this side. So in general, I'm going to write this as ax plus b, whereby a and b are just some arbitrary constants that I'm going to figure out. We will get to why I'm using this triple stacked equals once we get to algebraic identities. So I'm going to not expand, but multiply the x plus 1 over. So we get ax plus b multiplied by x plus 1. Now here we're going to expand the brackets. I am going to do this slightly quicker. You can of course check this yourself, but another way I tend to do it is to note what combinations I can get particular powers. So what I mean is that there's only one way to get an x squared, and it's by multiply the ax by the x, so I get an ax squared. Now what ways are there to get an x? Well, I have the ax times 1, but also the b times x. And then lastly we have the constant term, which is just b. Now note that these expressions are equal if and only if every single coefficient matches up. So what I'm going to do is I'm going to compare the coefficients for the x squareds. So if we have an x squared on the left hand side, we must have an equivalent x squared on the right hand side. So if x squared is ax squared, that's true if and only if a equals 1. And similarly, we were pretty much given the constant term for free, because the constant on the left has to equal the constant on the right. So in this particular instance, x squared plus 3x plus 2 all over x plus 1 is equal to x plus 2, subbing that information back in. So that was a fairly simple example. In the next video, I'm going to do one that's slightly more complicated. It doesn't require too much more algebra, but is more on the area of an exam style question.